Imagine waking up one morning and world has no mirrors, no reflection, no mirror selfies, no light bouncing off it.
Just darkness and confusion.
How would you comb your hair
How would you brush your teeth?
or even see your own face?
Now, flip the thought. What if the light did bend? Would a swimming pool still look shallow?
Or would eyeglasses on camera exist?
Well, today I, Ritvi,
And I, Yuti,
are going to take you all through a journey of invisible world. Welcome to the chapter Light
Reflection
and Refraction. Introduction to light. Light is a form of energy which enables us to see objects. It travels in a straight line and also exhibits reflection and refraction. Rectilinear propagation of light means light travels in a straight line. Speed of light is the speed at which light waves propagate. Speed of light in vacuum is 3 into 10 raised to the power 8 meters per second.
reflection. Light is a part of electromagnetic waves, and reflection is nothing but the bouncing back of light when light strikes a shiny or polished surface like mirror. And there are two laws of reflection. First law is that angle of incidence is equal to angle of reflection, and second law is that normal angle of incidence and angle of reflection lie on same plane. This is the normal, this is the angle of incidence, and this is the angle of reflection, and this is the mirror.
Now, let's move forward to types of reflection. There are two types of reflection, regular and irregular. Regular reflection, it occurs on a smooth surface and gives a clear image. This is the incident ray, and this is the reflective ray. Irregular reflection is also known as diffuse reflection. It occurs on a rough surface and does not give a clear image, as you can see here.
Now we also have lateral inversion, which means a phenomenon where an image appears reversed from left to right. For example, when you stand in front of a mirror and you raise your right hand, it appears in the mirror as if you are raising your left hand. And there are also some characteristics of plane mirror which you have already studied in your previous class, like image obtained is virtual and erect by plane mirror, and image is laterally inverted. Image is the same size that of the object, and it is at the same distance as the object is from the mirror.
Spherical mirrors. There are two types of spherical mirrors, concave mirror and convex mirror. Concave mirror, the reflecting surface is curved inwards. For concave mirror, the reflecting surface is curved inwards. This is the center of curvature. This is the focus, and this is pole. And this is the principal axis. Convex mirrors, the reflecting surface is curved outwards. Now let's understand its properties. Pole. The center point of the reflective surface is called as pole. Now center of curvature. The center of the sphere of which the mirror reflecting surface forms a part. Principal axis. It is an imaginary line. Focal length. It is the distance between the principal focus.
Now we also have a relation between focus and radius of curvature, that is radius is equal to 2f. Radius is twice of focal, or we can say that focal length is half of radius, which means if radius is 4, then f is equal to 4 by 2, which is 2 centimeters. Let's move forward to ray diagrams, concave and convex. First, let's understand the rules of the basic rules of making a ray diagram. First, if a ray is parallel to principal axis, then it passes through focus. Like in case of concave mirror, this is the focus, this is center of curvature. If the line is parallel to the principal axis, then it emerges through focus. Second is if a ray passes through focus, it emerges parallel to principal axis. Like if the ray is passing through focus, it will emerge parallel to principal axis. Third, if a ray passes through center of curvature, it reflects back along the same path, which is if the light passes through center of curvature, reflects back. Now we have 6 cases in case of infinity, then the image is produced at the focus. You can see the ray diagram in your textbook, and the image is highly diminished or point size and is real and inverted. Now if the object is placed beyond C, then the image will be between F and C, and it will be diminished, real and inverted. Only in the 6th case of concave mirror, that is when the object is placed between P and F, the nature of the image will be real, virtual and erect, and the image will be behind the mirror and the size of the image will be enlarged. The third case, when the object is at C, the position of the image will be at C, size of the image will be that of the same size, and nature is real and inverted. If the object is placed between C and F, then image will be formed beyond C, which will be highly enlarged or enlarged and real and inverted. Now, if the position of the object is at F, the object is kept at F, then the position of the image will be at infinity, which will be highly enlarged, again real and inverted. Now, there are two cases in case of convex mirror. First, when the object is at infinity, the image will be formed on the focus and it will be highly diminished or point size, and it will be virtual and direct. In case of convex mirror, the nature of the image is always virtual and direct. Second case, if the object is placed between infinity and the pole which is P of the mirror, then the position of the image will be between P and F, and the image will be formed behind the mirror. Therefore, V will be it will come further. Size of the image will be diminished and nature will be virtual and direct.
Now let's move forward to mirror formula. Uses of concave mirror and convex mirrors. Concave mirrors are used in torches, headlights, and shaving mirrors, while convex mirrors are used in rear view mirrors of vehicles. Now let's move forward to mirror formula. It is represented by, the formula is 1 by F is equals to 1 upon V plus 1 upon U, where F is focal length, V is the image distance, and U is the object distance. Magnification. It can be represented by height of image upon height of object. HR is the height of image. And HO is the object height. It can be also written as minus V upon U, means image distance upon object distance.
Let's solve some numericals based on mirror formula and magnification. Now first, if the radius of curvature of a convex mirror is 3 meter, object distance which is U, object distance is always negative. And focal length, what is focal length, what is image distance, what is height. Let's understand sign convention first. Now, all the distances are measured from the pole. Now, suppose this is the graph and this is the pole. Now, distances measured from left of the pole, which is this side, is always positive, and from the right side, the right of the pole is left of the pole is negative, yeah, and right of the pole is positive. Distances measured above from the pole are positive and below the pole are negative. Let's understand this in the form of table. first, the focal length for a concave mirror. Now the focal length for a concave mirror means the distance between focus and pole of the mirror. Therefore it is negative. U is always negative, as we all know. F for a convex mirror is positive. F for concave lens is negative, and F for convex lens is positive. U is always negative. Now V for a concave mirror is negative in first 5 cases, whereas in 6th case, where the image is virtual and erect, V is positive. In case of convex mirror, V is positive, and in case of concave lens, V is negative, and in concave lens, V is negative, and in convex lens, V is positive in first 5 cases, but in the 6th case, it's negative. This is the sign convention table. Now, let's solve some numerical based on this. Now, in a convex mirror, the mirror is already given. Radius of curvature is 3 meter. U is minus 5 meter. V is 1.15 meter. What is F? Height of image. I would like one of you to solve with me.
Just can you write the nature of them? And please convert it into cents.
0.23. पर ठीक है.
0.
produces image on screen of magnification -1, placed 50 centimeter away from mirror. What is the type of mirror? Image distance, focal length, and also draw a ray diagram. Amit, would you like to solve?
Please continue.
First, identify the type of mirror.
That's 30 minus, that's not 30, that's minus 50. You. Refraction of light. Bending of light from one medium to another is known as refraction of light. There are two laws of reflection. When incident ray, reflected ray, and the normal ray all lie in the same plane. The second one is the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is constant, which is N1 sine 1 is sine theta 2, where N1 stands for refractive index of medium 1 stands for angle of incidence, N2 stands for refractive index of medium 2, and theta 2 stands for angle of refraction. Refraction by glass lab. This is the normal ray. This is the medium 1, which is L. Medium 2, which is glass. When the light ray enters from the air into the glass slab, means it enters from the rarer medium to the denser medium, so it bends towards the normal. आप लोग ऐसे भी समझ सकते हो, आर.डी. शर्मा को नॉर्मल पसंद है. And as the light ray exists from the glass slab into the air, this happens when the light is traveling from the denser medium to the rarer medium. Means dr, denser to rarer, so it moves away from the normal. जब डॉक्टर को नॉर्मल लोग नहीं पसंद है. You can also understand by this trick. This phenomenon is governed by Snell's law, which relates angle of incidence and angle of refraction.
Now let's understand refractive index. Refractive index is nothing but the extent of bending of light. Light bends towards normal when entering denser medium and away when exiting a denser medium. The extent of the change in direction that takes place in a given pair of media is expressed as refractive index. Now, let us take an example of air and glass, where air is medium 1 and glass is medium 2. Refractive index of medium 2, which is glass, with respect to medium 1, can be written as speed of light in medium 1, which is v1 in air, upon speed of light in medium 2, which is glass. Or if we consider, which is n21, which means refractive index of glass with respect to air. And now if we consider refractive index of medium 1 with respect to medium 2, then it is written as n12, and velocity of light or speed of light in medium 2 upon speed of light in medium 1. Now there is also a term called absolute refractive index, where its formula is n equal to c upon v, where c is speed of light in air or vacuum, which is 3 into 10 raised to 8 meter per second, and V is refractive index of medium 2. Now let's solve some numericals based on refractive index.
Now, the first one is, can I erase this? First, I will read the question. At what distance from a concave lens of focal
Question 1. Refractive index of water is given as 4 by 3 and refractive index of glass is given as 3 by 2. And we have to find refractive index of glass with respect to water. Anyone? Yeah. Next numerical. Speed of light in air. Sorry, speed of light in a medium is given as 2.5 into 10 raised to 8 meter per second. Now what is the absolute refractive index?
So the speed of light in vacuum is 3 into 10 raised to the power 8 upon, and the speed of light is 2.5 into 10 raised to the power 8 meters per second. So speed of light upon speed of light in vacuum. 1.2 meters per second. 1.2 meter. Now let's move forward to lenses. Lenses are the transparent materials bounded by two curved surfaces. Convex lens, which is convex lens. Convex lens, which is thicker from middle, and it is converging. And convex lens, concave lens, which is thinner from upwards. Now let's understand the ray diagrams of lenses. So the first one is when the object is kept at infinity, the image will be formed at focus 2. The relative size of the image will be highly diminished or point size, and the nature will be real or inverted. In second case, if the object is beyond 2f1, the position of the image will be between f2 and 2f2. The relative size of the image will be diminished, and nature will be real and inverted. Third case is at 2, if the object is kept at 2f1, means at focal length 1, the position of the image will be formed at f2, 2f2, and the relative size will be the same size, and the nature of the image will be real and inverted. If the object is kept between f1 and 2f1, the position of the image will form beyond 2f2, and the relative size of the object will be enlarged, and nature will be real and inverted. If the object is kept at focus 1, the position of the image will be formed at infinity. The relative size will be highly enlarged, and nature will be real and inverted. The last case is when the object is kept between f1 and the optical center. The position of the image will be on the same side of the lens as the object. The relative size will be enlarged, and the nature will be virtual and erect. For concave lenses, there are two cases. If the object is kept at infinity, the position of the image will be formed at f1, and the relative size will be highly diminished or point size image, and the nature will be virtual and erect. If the object is kept between infinity and the optical center of the lens, the position of the image will be between focus 1 and optical center. Relative size will be diminished, and again virtual and erect. The nature will be virtual and erect.
Now let's move forward to power of lens. Power of lens is the degree of convergence or divergence achieved by lens after refraction, and its unit is diopter. Now the key point to learn in this is, more the refractive index, then the light will bend more, but the focal length will be less. This is the relationship between power, focal length, and refractive index. Let's solve some numericals based on lenses.
So first I will read the question. At what distance from a concave lens of focal length 20 centimeters? Means the focal length is 20 centimeter. Can anyone tell it will be minus 20 or plus 20? Wait, let me read the whole question. At what distance from a concave lens of focal length 20 centimeter, a 6 centimeter tall object is placed so as to obtain its image at 15 centimeter from the lens. Calculate the size of the image formed. Draw a ray line.
Focal length will be negative.
It will be minus 20 centimeter. The height of object is given 6 centimeter plus 6 centimeter, and width is minus 15 in the case of because it is given concave lens. So in the case of concave lens, it will be negative. Calculate the size of the image formed and also draw a ray line.
Hithvi, can you please pardon the question and break down and explain it to her so that she'll solve?
Can you give me a minute, please?
further towards a tricky numerical. An object is displaced 15 centimeter towards the optical center. Then, where would the image be formed? If M magnification is -1 and object distance is 25, sorry, image distance is 25 centimeter. What is the object distance? And magnification if sorry, object distance
Can you please explain the question?
magnification is -1, image distance is 25 centimeter, we need to find U and F. Now, in this case, first we'll find the object distance normally as we do from lens formula. Then, the question says that if object is displaced 15 centimeter towards the optical center, हाँ जो भी u आएगा तो 25 माइनस u will be our new u. उसके बाद उसको यूज करके हमको रे डायग्राम बनाना और फिर नया v भी निकलेगा. जो इमेज डिस्टेंस है वो भी न्यू फॉर्म होगा और ऑब्जेक्ट डिस्टेंस भी न्यू होगा बट फोकल लेंथ तो वही रहेगा. लेट मी सॉल्व नाउ. By lens formula, 1 by f is equal to 1 by v minus 1 by q. 1 by 12.5 is equal to 1 by 25 minus 1 upon q. We got the first u as minus 25 centimeter. Now the question says that the object is displaced 15 centimeter towards the optical center, which means minus 25 minus 15 is our new u.
Minus 40. Answer will be.
अच्छा, sorry.
Minus 10.
So now we got our new u as minus 10. We need to find v and f will remain same as focal length change नहीं होता है.